The first satellite instrument capable of detecting lightning across Europe and Africa has been switched on, and has now delivered its first lightning data. But before we get into it, what is the Lightning Imager? The Lightning Imager, built by Leonardo, is onboard Europe's latest weather satellite, the Meteosat Third Generation Imager, which launched in December 2022. The imager can continuously detect rapid flashes of lightning in the Earth's atmosphere, all from a distance of 36,000 kilometers. The instrument has 4 cameras covering Europe, Africa, and parts of the Middle East and South America. Each camera can capture up to 1,000 images per second, whether day or night. It can even detect a single lightning bolt faster than the blink of an eye. Equipped with the data, weather forecasters will be able to better track the development of severe storms, and will also contribute to the study of weather phenomena and air transport safety. So let's get to it. The Lightning Imager's north camera faces Europe. Here we can see lightning in early June 2023. Local thunderstorms develop daily in southern Europe during the warmer part of the year. Some larger and more persistent tropical storm systems can be seen in West Africa in the bottom left corner. If we take a closer look a week later, local thunderstorms appear in the central and southern parts of Europe in the afternoon. More persistent storm systems can be seen over the Mediterranean, staying active throughout the night. Short-lived isolated storms can be seen forming in the southeast and west areas of the UK and further north in Scotland. Very intense lightning activity occurs continuously in Africa. Local thunderstorms appear in the afternoon and disappear shortly after sunset, unless they develop into larger storm clusters and can stay active throughout the day and night. Central Africa is recognized as the most active lightning region in the planet. This animation shows the continuous lightning activity across the region. Most of the time, especially during the afternoon and evening, thunderstorms cover a considerable part of the area. This animation of the Sahel region in northern Africa demonstrates the Lightning Imager's ability to monitor single convective systems in great detail. This close-up view shows the westward movement and evolution of a big cluster of tropical thunderstorms. Lightning is more frequent in developing storms than in parts of the storm system that are already mature. The Lightning Imager's south camera observes the southern Atlantic Ocean, with the southernmost part of Africa visible in the bottom right. Much less lightning is visible here than the instrument's 3 other cameras because most of the field of view is ocean, whereas most lightning occurs over land. The west camera covers the Atlantic Ocean, a small part of Africa, and South America. This animation shows the intertropical convergence zone, where clusters of tropical thunderstorms are slowly moving from east to west. If the waters are warm enough, some of the larger storm clusters can develop into hurricanes, affecting the Caribbean and the east coast of the United States. Sun glint, the reflection of the sun from the ocean and smaller bodies of water on land, can also be seen. Each animation shown here contains a sequence of images created by collecting 1 minute's worth of lightning data, overlaid on a single image of Earth. While these are just the first results from the Lightning Imager, the satellite is still undergoing its commissioning phase, where the instruments are calibrated and the data is validated. The data from the Lightning Imager will be available for operational use in early 2024. For more information on the Lightning Imager and access to the animations, visit ESA.int/MTG. Thank you for watching.